So next, I'd like to invite Mr. Naveen Mukesh, Technical Engineer from Entu Technology Solutions India Private Limited, Coimbatore, to deliver on the topic Precision Agriculture using AGI and IoT. Over to Naveen Mukesh. You can start your presentation. Naveen Mukesh, are you on the line?
Yes, sir. Good morning, sir. Is my voice audible?
Yeah, your voice is audible.
Yes, sir. Just share my screen.
Yeah.
So good morning, guys. Myself, Naveen Mukesh from Entu Tech. I'm a senior technical engineer.
Sir, you can drop down that meet.google.com sidebar to below so that your entire screen will be visible.
Okay, sir. Okay, sir. Thank you.
Okay. Just it's now fully clear. Yeah.
Yes, sir. Thank you, sir. So myself, Naveen Mukesh from Entu Technology. I'm a senior technical engineer working on this ANML for past 3 years. So first, I'll just give a small intro about my company. So my company is founded in the year 2007 by a group young entrepreneurs and later incorporated as a private limited company in 2015. Entu Technology emerged as a next generation technology company, which headquarters in Coimbatore. So the company operates in domains of electronics manufacturing, IoT, and embedded system with a strong focus on delivering end-to-end product development solutions. So while coming with the company, what are the process we are just doing here? I just listed out some of our process. So we are just expertise in transforming ideas into the real world products. So while the customers carry out with the ideas, we are just converting them into real world products. So the service covers the entire life cycle of product development, including the hardware device and the prototyping, software and the embedded system developer, and the PCB design, fabrication, assembly, including that IoT cloud platforms, mobiles, and website application. At last, we are just delivered the product to the testing team. So the product tested and deployed in the site itself. So from the base idea to a end product will be converted by our company itself. So here I just have some key points like just working on this here for 18 plus years of operation, and we have more than 100 plus of employees. So while coming with the cloud, we are just receiving 1 million data every day, and we are just deployed 100K devices all over the world, all over the India, all over the India, and we have 1,300 plus satisfied customers. And as academic part, we also just established some labs and we are just training students also. So I just established 470 plus labs, including just working on the Idea Lab also. While coming with the students trade, we are just trained 50K plus students. So this means that we can approach Entu Tech for just an idea. So if you have just have any idea, we can approach Entu Tech. The company can deliver the fully functional market-ready product. So while coming with we are just working on key technologies. While working with the journey, so we are just started with a training and distribution company, and we are just include the development, embedded development, and we are just introduce our EMS also, so electronic manufacturing services also. Along with that, we are just introduce the PCB made so the new machines for the PCB and the SMT services. So SMT is nothing but surface mount technologies. So we are just working vast on surface mount technologies also, and then we are just entering into IoT consulting and IoT projects, expertising that. And then at last, we are just now we are just working with the UAE also. So just expand the marketing to UAE also. So we are just deployed more than 100 devices in UAE also. So we are just mainly focusedly working on Internet of Things in the main communication called LoRa and LoRaWAN. So while coming with the LoRa and LoRaWAN, in a real-time systems, while you are thinking that just using mobile, you're just using a Wi-Fi or Bluetooth technology. So you may know that the Bluetooth technology will cover around 700 to 800 meters only in field level. So while coming with the Wi-Fi, so with the help of I can push the data to the cloud. Means, for example, if you consume mobile phone, for Wi-Fi it will consume more power. So we cannot operate in the battery level. So let us consider a scenario. So in that scenario, if you have 100 plus trees, so if you have 100 trees, you need to install some soil moisture sensor. I'm just installing this soil moisture sensor. So for 100 devices, I'm just every day I just go and plugging the power means it's quite impossible. So I need to move on to my communication into a battery operated communication. So only I just entered the LoRaWAN solution. So we just enter the LoRaWAN communications. So yeah, just to proudly tell that they are members of LoRaWAN Alliance. So and then you're just working on PCB manufacturing and SMT assembly. So we're just designing from the base to designing and fabrication of a single layer board to double layer board or multi-layer board. Along with that, we are just inserting the components like SMT components or through hole components. We are just inserting, and at last we are just perform some testing and we are just delivering the PCB product also. While coming with the advanced technologies like artificial intelligence, machine learning integration, we are also working on that. We are just deployed many devices in the Jetson or Nano. We are just providing some end devices in the Jetson Nano Raspberry from Raspberry Pi to the advanced model of Jetson Nano Google Coral board like that. So at last we are just working on industrial automation, smart systems. So while coming with this smart systems, so we're just working on smart agriculture, smart cities, industrial IoT, smart healthcare, and the connected vehicles. So how we are expertise in the four, we are just categorize this complete process into four categories. So first is our R&D division. So in our R&D division, we have two teams. The one team is product success team. So I just explore on products and you just explore on new technologies and they just deliver the product, and the testing team. So the testing team will support the product to working on different conditions. So while coming with the EMS product and services, they are just providing the SMT components, PCB boards. They are just providing the single layer board designings up to fabrication. Everything they are just providing. And while coming with the electronic system design manufacturing, they are just dealing with the machines, heavy machines of PCBs and all. And at last, they are into academic solutions. So they are just they are just building a bridge between the corporate to the college to the corporate, because every students are fully capable of learning, but while coming with the hands-on works, so they are just from their college age, they are just learning the papers alone. While coming with hands-on, it's quite challenging while coming into the corporate. So to solve this problem, we are just to build a bridge between the college to corporate. We are just providing more hands-on workshops, hands-on training. So everything we are just doing here. So these are key achievements. So we are just we are just funded a small project in from a startup Tamil Nadu based on LoRaWAN networks across to Coimbatore and Salem. So we are just signed a partnership with Gorilla Link, a famous company, and from our LoRa Alliance member, we have just received an innovation award in Florida. So I'm coming with business, as I already discussed that we are just expand the business in UAE market also. So I just signed with the MOU with ICT Academy also, and a MOA with our University also. So these are key partners. So LoRa Alliance member, especially just working on LoRa, key partner LoRa Alliance member. So while coming with our focusing, we are just focusing on Gorilla Link, Startup Tamil Nadu, ICT Academy also we are just a tie-up. Space Loka, we are just working on satellite communication. And in non-Mudaran also, so while coming with the government project, the specific famous non-Mudaran also we are just working. We are just training the engineering graduates. We are just training the polytechnic graduates based on non-Mudaran also. And we are just hiring from there itself. So while coming with our academic academic services, one unique aspect of EdTech Technology's contribution to education through EdTech academic solution. They work closely with the colleges and institutions to establish advanced IoT and AI labs, provide hands-on training and workshops, support students in building real-time industry projects. So this helps bridge a gap between the academic learning and the industry requirements. So at last, I just say my vision and impact. So while coming with NT Technology aims to drive digital transformation by enabling business and startups to adopt small technologies. They also support startups to help them to set up PCB manufacturing and a product development ecosystem, making innovation more accessible. So this is just complete my company intro. I'm just enter into my today's topic. So today we are just here to discuss about precision agriculture using HGA and IoT. I hope so. My screen is visible.
Yes, yes, yes.
Yes, sir. Thank you. So let me start with a simple question. So have you ever wondered how the farmers decides when to water the crops or how much water to use? For generations that from here we are just getting some answers like it may be based on experience or the intuitions or sometimes it may based on their uh, experience also intuitions also like that. So but today we are just entering an era where farmers decisions are made using data intelligence and automations. So that's exactly why I'm going to talk about precision agriculture using AI and IoT. So let me walk you through a journey today. So, well being understanding the challenges in traditional farming, then we'll explore how IoT brings visibility. After that, we'll see how HEA adds intelligence. Then we will connect everything into a complete system. And finally, we will look at a real world application and what the future holds. So today's agriculture. Sorry. Today's agriculture. So what is agriculture today? So just a processing manually, and it's a weather dependency. So based on whether it get trained or whether it not get trained. So based on not only we are just growing the plants and the water wastage. So the tank leakage, the water consumption with the plant. So we are just today only we are just today night we are just water the plant. Tomorrow morning it will be heavy rainfall. So it may cause some water wastage, and while coming with the productivity, the traditional way will just provide a low productivity because of the diseases, insects. So imagine a farmer standing in the field early in the morning. He looks at the soil, feels with his hand, and decides maybe today crops need water. Now sometimes he is right, but sometimes he is not. And that small uncertainty can lead to a big problem. Too much water can cause damage to the crops. Too little water can reduce yield also. So, in fact, agriculture consumes nearly 70% of global fresh water, and a large part of its waste due to its inefficient practices. Added to this unpredictable weather, climate change, and labor shortage, and we'll just start to see the real challenges. Farming today is not just hard; it's uncertain. So we are just entering the precision agriculture. So in today's world, we are just doing this precision agriculture. So now imagine a different scenario. So instead of guessing a farmer getting a notification, soil moisture is low. So in a mobile phone, a farmer is getting some notification that soil moisture level is low in the specific area. So I'm just cultivating for 10 acres of land. In the specific areas of 1 acre, the soil moisture is low. So it needs some irrigation. If they are just seeing some notification like that, it's about replacing guesswork with data. So I'm just replacing the guesswork. So I'm just touching a sound. I'm just telling that it may need water or not. Behind that, I'm just with the help of my data, with my help of my accurate data, I'm just replacing my guesswork. So instead of treating the entire field the same, we are just teach each part based on the exact needs. So because somehow with hold the underground water in a high level, somehow the underground level must be very little. So based on the area, we are just watering means it will just reduce the water quality, and it will also improve the plant quality also. So it's like giving a personal care, but for crops. So we are just giving some personal care, but for crops. So in precision agriculture, I just taking some data-driven farming, and I'm just using some sensors, AI, and automation, and I'm just optimizing the water, fertilizer, everything. So why do we need it, and why is this so important today? So because the world is changing rapidly. So by 2050 we need to feed nearly 10 billion people as per the data. So in the year of 2050 we need to feed nearly 10 billion people. So it's quite a large count. At the same time, water has become scarce because everyone know around 85% of the water is salt water. Only for 15 is a fresh water available. So within the fresh water, we need to do some agriculture. We need to run some industries. We need to do some our day-to-day needs. So we need to fulfill our day-to-day needs with this 15% only. While we are consuming the fresh water again and again, the water will become scarce. So and the farmland is also limited only. So if you take all over the India, our Tamil Nadu is very famous for the farmland. Another that the Punjab is too famous. So like that we are having only little farmland. It will not capable of feeding 10 billion people, sir. So and the labor is also getting decreased. So while coming with the labor shortage, everyone gets graduate, everyone just enter into the few technologies, working on the office. Then the agriculture labor is also getting decreased. So my question is, how do we produce more with less? So just having less labors, we are just having climatic change rapidly, we are just having increasing population. So we are just need high lead. So how will we produce more? So for that only, this question only will rise that we are just use some technologies on agriculture, and I'm just using some sensors, some AI technologies, and I'm just developing from here, and I'm just leading into a future technology. So before going to advanced technology, I'll just tell a small point about the IoT. That's nothing but Internet of Things. So while coming with embedded system, as previous speaker speaks about completely the edge IoT. So the edge AI concepts. So the embedded systems will play a key role with the help of this edge AI also. While coming in the cloud, it will take some little delay. I'm just in the forthcoming slide, I'll just discuss about what is on the edge AI and all. So here I'm just discussing about the IoT. So before going to AI, for me, the IoT is enough to monitor my all the data. Eventually, if the edge AI also came there, my process needs to get automated. But while coming with my data visualization, it needs to be moved to the cloud. Then only I can see my data from everywhere. If I am in my office itself, if I'm in my home itself, if I'm somewhere to my native also, I can see the data, I can monitor my land from anywhere. So while coming with the edge AI, along with this cloud for data updating around, it's a quite advanced solution for the agriculture, not only in agriculture, for all the industrial factors. So while coming with this internet things, so it's nothing but the connecting a physical object to the internet. I'm just connecting some physical, I'm just connecting my sensor to my internet like that. So in agriculture, these things are sensors placed in the field only. So these sensors continuously absorbs what human cannot, because human will not monitoring the soils or moisture sensor in 24 hours. And while coming with the leaf moisture, while coming with the NPK, so NPK is nothing but nitrogen, potassium, and calcium. So the plant's necessity is this NPK concepts. So we will not manually visualize the NPK concepts. We need to take them and we are just to go for lab, and we are just to test it in for every 2 to 3 months. While coming with the sensor is quite become advanced, so we can monitor each and every second our data. So I'm just discussing some concepts about IoT. So how can I apply this IoT in agriculture? So let's take a simple example. A soil moisture sensor is placed in the ground. Instead of guessing, the farmer knows the exact moisture level. So I'm just placing some soil moisture sensor. Instead of guessing, just seeing the soil and just it's dry. Maybe in under soil it may get more wet. So it will not visualize on the top layer. So instead of guessing, I'm just going with my accuracy, data accuracy. For that, I'm just installing some soil moisture sensor. If the soil become dry, the system detects it instantly. So it's like giving the farm a voice. It can now tell us what it needs. So the plants can speak. The plants have some feelings. So the plants will tell, now I just need some water. Now I just need some food. I just need some sunlight. So those plants can speak with the farmers. So to give a better yield, to become a better work, we need to communicate it in a proper way. For like that only, we are just introduce the plant to communicate with the farmers to bring a better yielding purpose. So, while coming with this IoT components, we are just initially just discussing about the IoT. While coming with this IoT components, behind this simple idea, it's a powerful system. Previously I'm just telling about the IoT. It's a simple device. So behind we have a powerful system. The first thing is our sensors. Sensors is nothing but it will just convert the physical data into the electrical signal, like our sensing organs. So in our body, we have five sensing organs like eyes, nose, tongue, skin, and ears. So what is the work of this five sense organ? Means our eyes will convert the environment into a pictorial format. Our ears will convert the sound into a neural signal. Our tongue will convert the taste signal into a neural signal. And our nose will convert the smell into a neural signal. Like this, our sensor also converting the physical parameters like our wind, temperature, wind speed into a electrical signal. So this is the major role of the sensor. So I'm just to give some example here. What other things it get captured like moisture, temperature, humidity. So apart from this, we have 1 billion kinds of sensor to measure different factors like NPK, soil NPK, leaf moisture, and then the soil moisture level, water level, and then the a ripened state. So whether the fruit gets ripened or not. So everything have unique sensors. While coming with our controller, it may be a microcontroller, microprocessor. Both the way we can use. So while coming with the controller, we have a ESP32, STM32, or from Arduino, we have advanced like STM32 also. While coming with our processor, so based on the application, I'm just working on with the image application means I can move on for my processor. If I'm just using it data alone means I can move on for my controller itself. While coming with the processor, we are just using starting from Raspberry Pi to Jetson and Google Coral as we have previously discussed. We can use it here. While coming to communication, we are just using more power consumption factor means you can go for Wi-Fi, or else I'm just not using more powerful consumption idea means we can move for LoRa. So at last, the dashboard for visualizing the data. If some customers need to view the data, if the most of the agriculture is not yet educated, till I am just entering to the field, I'm just facing that farmers are not that much educated, but they are understanding the smartphones. They are just understanding the languages. So to make more simpler, we are just designing them and dashboards concepts and all. So at last, I just come to this slide. So behind the simple ideas is a powerful system. Sensors just collect the data. A smart device like ESP32 to process it, and the communication system send the data and dashboard display it. So it's a complete loop. It works like a loop. So from sensing to a decision making. So the sensor will just push the data to the controller. The controller will take some decision like whether it need to get water the plant or not to get water, not water the plant. So based on the temperature also, it will just decide whether it will get watered or not watered. So while coming with the communication, based on the controller. So yeah, while coming with the communication, I'm just data into the cloud. So we are just using Wi-Fi or LoRa to push the data to the cloud, and based on the cloud, we are just building the dashboard, and we are just enter into the physical layer to the application layer. Based on the application layer, we just visualize to the customers and all. So now I am just entering to the main concepts called AGA. So in many of the places I am just visiting, I am just giving this solution called AGA without pushing the data into the cloud. Because the AI we need to run on itself. It need to take the decision by itself. It not depend on any other platforms due to the fast response. But collecting the data is not enough. Previously, I just say about the IoT, but collecting the data is not enough. We also need some intelligence. That's this why we are just entering the AI comes into the play. So Edge AI means analyzing data directly on the device, right there in the field. In field itself, will just analyze the data and it will just take some decision and it just share the decision with the respective devices and make it process. So instead of our brain, so here I'm a decision maker. Instead of our brain as a decision maker, I'm just building an intelligence. So I'm just building up another brain which will just take care of my agriculture alone. So for my agriculture alone, I'm just developing some brain and make them that it will someday make its own decision. So I'm just leaving my agriculture land with the intelligence. So that my yield may get very good. My yield may get more, and my expectation. So my profit is also may get more. So uh, what is the benefit of this AGA files? It means there's no waiting. So there is no waiting for cloud response. Somehow if we go for LoRa means there is no downlink receiving means so it will just waiting for its response. Then only it will take action. For example, I'm just having a paddy field in my native. So in the paddy field, it will just suddenly get fired. So due to some certain reasons, it will get some fired. So the flame sensor just detect the fire and it will just send to the cloud that the temperatures are rapidly high. I think so, the smoke is detected. I think so. The plant is got fired. Then the cloud, the device may get maybe in rural area. We have slow internet connection, so the response will get very slow. So after completely get fired and after converting to ashes, it will just started the watering. So this is how the cloud AI works. So after that, watering is not a good solution. So like that process only, I just introducing the edge AI concepts. Just initiate that decision. So we'll just see a small difference between the edge AI and edge AI versus the cloud AI. So as we have already discussed about the scenario, traditionally data GAA is very fast. So comparing to cloud AI, it's very fast. So while coming with internet, so it doesn't need internet. While coming to cloud AI, it will just need some internet. While coming with the process, it's lower long term, and while coming to cloud, it will take more time. So why edge AI in farming? So here I need to speak a lot of words here. So initially I just start with the scenario. So imagine this situation. So
Naveen, sir,
yes.
last 5 minutes more. Kindly look into that, sir. Thank you.
Yes, sir, I'll just make it first, no issues. So just tell a small points here without explaining everything detailedly. So imagine this small situation. The soil become extremely dry right now. So we'll just wait for data to travel to the cloud and come back. So or we take the action instantly. So we now just a scenario, just to compare with our body. Now I am just hungry. So I'm extreme hungry. So I have an option. I have a noodles in front. Within 2 minutes, I can prepare the noodles. I'll just go with the solution. Or else I just go for Swiggy. I'm in a village side. I just go for Swiggy and just wait for my food for 1.5 hours. It's a better solution. So I just go for the noodles only. So like that only, the Gen cloud computing. So here the GI becomes a more immediate action. It also works on a remote area also. It will just take some real-time decisions, saves the bandwidth and the faster response. So this can make the difference between the healthy crop and a failed one. So while coming with the system architecture, now let's connect everything. So I'm just having a separate concept called IoT, and I'm just having a separate concept called AGAI. I'm just integrating both the IoT and AGI and just giving a better solution. So the sensor will collect the data from the field initially from the IoT and gets to collect the data from the field. The data goes to the edge device. So instead of reaching the cloud, it will just reach the edge device itself. Then the AI model will analyze it, and based on the result, the actions taken, whether the soil is dry or soil is wet, whether climate is too sunny or too day. So I can also generate some futuristic data. Based on the futuristic data, also I can take some decision. For example, let us consider field. So in my field, I am just having a agriculture land. So in my field, uh, tomorrow it will get rain. So based on the temperature sensor, I'll just calculate the futuristic data. Okay, it will just rain tomorrow. So today I'll just water little. It's enough to my plant. So instead of that, I'm just fully depend on IoT, means it will just completely give water to that. After the rain, also it will get more water. So it will affect in the two ways. The first way is just wasting the water. The second way is the plant is also get rotent based on the more water conditions. So I'm just using some AI model to analyze it, and based on the result, actions taken. So it could be turning on irrigation, sending alerts, or predicting future conditions. So it can maybe any cases. So this is not necessary automation; it's an intelligent automation. So while coming to this edge AI, it's an intelligent automation. So while coming with the data, so down I'm just given it as a say soil mass equal to low. A predicts drainage. System turns on irrigation. It's a small, it's a sample data that they get it from my soil moisture sensor. So the soil starts drying. So what is the condition? Means the soil starts drying. So the sensor detect it. After that, I just reach this information. The sensor system need to analyze it. So system need to analyze it, and within seconds, the irrigation will get start. No human intervention. There's no human intervention. I didn't want to go there and need to on my motor. There's no human intervention. Just a smart system working in the background. It's like a smart system working on a background. Whether when it turn all it need the water means just take the water. When it all not need means it just stop the water. So while coming with the technologies used, so while coming with the embedded system, we have only two edge AI technologies. That's nothing but Edge Impulse that was introduced by the NVIDIA. NVIDIA just launched the Edge Impulse. While coming with the TensorFlow Lite, it was introduced by Google. So Edge Impulse is suitable for both the data and images. While coming with the TensorFlow Lite also, it's also suitable for data and images. But while coming with examples, it also suitable for basic microcontrollers like our ESP30, S3 module also. So, and it is based on web itself, we can develop it without introducing to the program. I'm just using Python program to train the data. It's not necessary to use the Python program in examples. I can just go for a web page, and I can just train to the web page itself. So all of this is made possible by powerful technologies only. For example, examples help to build AI models. TensorFlow Lite runs them on device. So we are just using this platform like Arduino IDE for programming purpose and all. And while coming with a dashboard and a cloud, we can go for free clouds like Blink or else the paid code also. So use cases. So I would like to discuss some more use cases here. So while coming with the initial use cases, I'm just first I need to discuss about the smart irrigation. While coming with the smart irrigation, this brings us one of the most impactful application, smart irrigation. So instead of watering the entire field only, the required areas are get irrigated. So based on the requirement, this can reduce the water usage by 30 to 50%. So think about the scale of saving when applied to globally. So in my field, I'm just saving my 50% of the water. While you think for a global savings means it will just bring fresh water to our future uses also. So the second thing is our disease direction. By coming to the disease direction, so I'm just imagining another problem is that plant disease. A small infection of if unnoticed can destroy an entire crop. So recently, I just worked with the Punjab project. There, I just insert some camera and I just monitoring the insects as well as the disease detection. So On that, I just explore more number of diseases, whether it's bad for plant, whether it's spreadable or not spreadable. So everything I just analyze, and I just analyze the conditions also for what this is going to cause, what are solutions. So it's quite a different chapter. While coming in the disease direction, it's different subject. So it's a big, it's a more data. So a simple camera will capture the image. The AI model understands the pattern, spots discoloration, and identify the disease. It's likely having a doctor for plants. So smart irrigation is like to save the water, and it will just speaking with the agriculture like that. While coming with disease detection, it's like a doctor for my plant. While coming with the farming, it's deeply connected to climate. As usual, we know the farming is completely dependent on the climate only. So based on temperature, humidity, and pressure, it will affect the growth. So by continuously monitoring these factors, farmers can make better decision, like when to plant, when to harvest, how to protect crops. So everything the farmers can know. So now let's scale this up. What if the farm is huge? I'm just having a extra 10 acre. I'm just having a farmland like 100 acres, 200 acres. What will the usage of human? I need to put more humans there. Instead of that, I'm just introduce that drone concept here. So they can scale large areas quickly, capture image, and even space fertilizers there. So it will just capture the field and it will just analyze the images also. Parallel to that, it is used for fertilizers also. So while just I'm just going with human means it will take some days, but now I can done this in minutes itself. So these are the use cases we are just using here. While coming with the benefits, so what we gain from all this? So instead of I'm just going for traditional method, if I go for this agriculture means what are the benefits I'll just gain? It'll just give higher productivity, lower pay, low water usage, reduce, and the most important, better data driven decisions. So my data decision must be in a better format. So while coming to my challenges and future scope, of course, no system is perfect. It has some challenges also. I'm just discuss about the challenges. Initial cost can be high. Yeah, definitely we need to insert some sensors. We need to insert some technologies. The initial cost may be high. Farmers also need some training based on the setups. So the technical knowledge must be a little for the farmers also. Uh, Connectivity can still be a challenge because some based on the field it will get varied. So in our office we are just working with it's quite easy to work. While coming at the field we have a more temperature because I am just facing this issue in my Jammu project deployment also. You can also know in Jammu and Kashmir the apple is more famous. We are just yielding some sensors to the in the Jammu. The temperature is extremely low where the PCB misbehaves. For that, we are just specially designed some PCB and they are just deployed there. So the climate is a major factor. So the climate, like that, the connectivity, everything speaks a lot. So while coming with the future scope, so looking ahead, the future is exacting. AI-powered robots, self-driving tractors. So we are just having self-driving cars. So in future, we have self-driving tractors also. So satellite-based monitoring. Farming will become smarter, faster, and more precise than even before. So from this, and just to conclude my speech here, so let me end with this thought. For centuries, farming depend on experience. Today is evolving into a science powered by data and intelligence. Precision agriculture using AI and IoT is just not an innovation; it's a necessity for sustainable future. So thank you for your time and attention. I hope this session gave you a new perspective on how technology is transferring agriculture. I would be happy to answer any questions.
Thank you, sir. Thank you for your wonderful keynote address for focusing on the agriculture-based innovations and initiatives taken by Entu Technology Solutions. Dear participants, if you have any doubts, you can unmute and ask, or else you can post in the chat box. There is no.
I'm having one question related to AI autonomous rover. Can you be? Are you able to work out for this AI autonomous rover design?
Sir, we are just working on devices only, with the edge devices only. the animal disease detection like that. We are just not entering into the robotic concepts and also. Just doing some R&Ds there. So now only we just introduce our on-arm robot. So in future scope we have, sir.
Okay. So afterwards, we can have detailed discussion about that. Okay. Thank you.
Okay,
Sir,
sir,
thank you, sir. Can I have one question?
Yes, sir.
Yeah, sir, definitely.
Sir, actually, I want to know the drone, these things, no, for the monitoring of those things what you are speaking, correct, no?
Yes,
So, what else that in the near future, like, no, people are already doing for the spray and survey, but what else can be done?
Sir, yeah, just install some camera. So because we have a larger time kind of field, means we just insert some camera. We can monitor the plant health also. So based on the precise camera, we can monitor the plant's health also. Based on the thermal camera, we can detect that is there any animal disturbances available there or not. So like that, we can develop it, sir.
Health, that means farmer, that they're monitoring for their health, plant health.
Yes, the plant health also you can monitor. So plant growth, especially the plant growth, because if you have a large farm field, means you need to visualize every area which I. So instead, I'm just inserting some drone. I'm just visualizing, means to just to show me the plant growth also. So how the growth is, how the yield is. So everything I can see via the drone itself, sir.
Okay. Thank you, sir.
Thank you, sir.
So any other questions by the participants?
Hello, sir. I have a doubt about the wireless communication.
Yeah.
Sir, our current project is we are working with smart irrigation based on offline, sir. We are focusing on RF communication method by using we are first focus on LoRa.
Okay.
But when we use the LoRa, we have faced some consequences and we use 433 megahertz. It officially not available in our India, so it's hard to buy a something at that frequency 900 frequency LoRa board, sir.
So while coming with our India, we are just following the Europe frequency only. It's 838 megahertz. So it's quite available in our industry, in our field itself. So we are just working many technologies on LoRa only. So everything is quite possible with within the Tamil Nadu. So we are just working with many colleges in LoRa. So now training also we are just handling with LoRa also. So that's possible only. I doesn't know what the issues you are just facing. So if you have any doubts, you can contact me. So I'll just support you. No issues. While coming with offline, you just go for AGI concepts. So with the help of any algorithm, just train it and make the decision by itself. Not to communicate it will just set some information to the user alone. I'm just agriculturing, I'm just watering my plants. So when that time I'm just reading it, it will just shows the data alone. The decision it will take with the edge device also. Like that we work it.
Sir, when we talk about the field data, we should need multiple data from the field, sir, because beyond the temperature and the soil moisture level and some weather condition, we should need more data. What are the other sensors beyond it have there, sir? It at least it need to cover a farmer budget, sir.
So we can use the NPK sensor, nitrogen, potassium, calcium sensor. This is for the plant. When I need to put some feeds there. So I need to put some feeds there. So for that I just use NPK sensor. While coming with the leaf moisture sensor, so in some cases, so leaf moisture is also a very big factor. So I need to install some leaf moisture sensor also. While coming, we can go instead of temperature and humidity alone, we can go for a weather station. There you can calculate 7 factors like pressures. So including that, the dust particles, the dust particle also important factor, and then the illuminance, the sun illuminance. How the sun illuminates, so we are in a technical area called as luminance value. So what is the lux value available there? So everything go with the weather station also. We can go completely depend for a weather station. Along with that, water level sensor. So how much water is available in my storage unit? So while coming with the paddy field and all, how much water is available in my field? So everything it is under notable only.
Of course, sir. Thank you, sir. And the last two questions, sir. What kind of microcontroller you prefer for the field side, sir? Because it should need to perform a good, and also it should mandatory to power level, sir. So, what kind of microcontroller you prefer for the field side?
While coming with the field, so you can choose based on the application only. I'm just using basic 2 to 3 sensors around. Means you can go for Arduino chips also. No, or else I'm just using more advanced technologies, more advanced concepts. Means you can go for STM32 also. So based on the application, you can choose the microcontroller, and you need to especially concentrate on the power given, because microcontroller mostly works on 5 volt only, but we'll not get the 5 volt directly from the electronic appliances and all. So it will just directly give 230 volt. So we need to convert the AC to DC there. So we need to convert the 230 volt into 5 volt. So everything is on the electrical circuit only. So
Of
based
course,
on the
sir, because
performance, based
we
on
have
the
only
need
power
only,
supply. Tell me, sir.
yeah, based on the application alone, we can choose the chipsets. That's not an issue.
Okay, sir.
Thank
Because we
you.
have a
Thank
power
you.
supply.
Yeah, Ashwin, we can take the more questions on offline.
course, sir.
If required, we can discuss with Naveen later. So time is
Okay,
running up. Thank you, Naveen sir, for your wonderful session.
Thank you, sir.
Thank you, sir. Thank you. So I will stop the recording and restart back for the final